Hello everyone, you're welcome to another exciting lesson on Math with Ella. We continue with our lesson on numerical methods, and today we are looking at the trapezoidal rule. And this is one of the numerical methods that can be used to approximate an integral. Generally, we use numerical methods to find the value of an integral when we cannot use any of the normal methods of integration that we know. So, one of these numerical methods is the trapezoidal rule and the other is the Simpson's rule, but today's lesson is focused on the trapezoidal rule. In some books, you see it called trapezium rule, so it's the same thing. So now here we have the trapezoidal rule given as integral from a to b of f of x dx. Of course, this is a definite integral. We use numerical methods to approximate the value of definite integrals. So, integral from a to b of f of x dx equal to delta x on 2 times f of x naught plus 2f of x1 plus until 2f of xn minus 1 plus f of xn. Now, looking at this formula, there are some things we have to take note of. The first thing we have here is delta x. We need to identify what delta x is. The next thing is that in the square bracket, the first term, which is f of x0, as well as the last term, which is f of xn, is not multiplied by 2. Meanwhile, all the other terms in between, that is f of x1 right up to f of xn minus 1, are multiplied by 2. That is something we have to take note of. And now we need to know what delta x is and what the various x naught, x1 up to xn are. So first we define what delta x is. Delta x is given as b minus a on n, where b here is the upper limit of a definite integral, a is the lower limit of our integral, and n here is the number of stripes. Trapezoidal rule, of course, we have divided the area under the curve into some stripes, and n here is the number of stripes. When using trapezoidal rule, our n will always be defined. So next we need to identify what x0, x1 up to xn are. So xi is equal to a plus I delta x. That is, x0 will be equal to a plus 0 times delta x. x1 will be a plus 1 times delta x, and so on till we get xn, which will be a plus n times delta x. That is it about understanding what is needed in order to apply the trapezoidal rule correctly. Now let us illustrate this using an example. So we have here our example. Use the trapezium rule with 4 stripes to find an approximate value for the integral from 1 to 9 of the square root of ln x dx. So let us approximate this integral using the trapezoidal rule or the trapezium rule. As I mentioned earlier, some books will have trapezium rule and others will have trapezoidal rule, or the same. So let us put our formula here so we know exactly what we need in order to solve this problem. So here we have integral from a to b. So in this case we have integral from 1 to 9 of the square root of ln x dx. So in this case we can identify our f of x. F of x, that is the function we're integrating, to be the square root of ln x. Now the next thing we need in order to apply the trapezoidal rule is delta x. Delta x, we said, was b minus a on n. b is 9 minus a, 1 on n. They said 4 stripes, so our n in this case is 4. So that will be 8 and 4, and that gives us 2. So delta x is 2. The next thing we need x0, x1 up to x4, because we have our n, number of stripes, is 4. So we are going to have x0, x1, x2, x3, x4. So x0 will be a We said x naught was a plus 0 delta x. So in this case, our a is 1 plus 0 times delta x. Delta x is 2. That gives us 1. X1 will be, again, a plus 1 times delta x, which gives us 3. X2 would be 1 plus 2 times delta x. That gives us 5. X3 will be 1 plus 3 times delta x. That gives us 7. And x4, a plus 4 times delta x. That gives us 9. So if you notice the pattern, we just keep adding delta x to the previous term. So you start with the first term, that will be 1. You add delta x, which is 2. You have 3. You add 2 to 3, you have 5. You add 2, you have 7. You add 2, you have 9. So take note, our x naught will always be the lower limit of our integral, and our xn, which in this case is x4, should always be the upper limit of the integral, because you're integrating from 1 to 9. So you should start from 1 to 9. Now we have our xi's. The next thing is to evaluate f of x0, f of x1, up to f of x4. Now let's look at that. Okay, we'll keep this over here. So we have the integral from 1 to 9 of the square root of ln x, the x being equal to delta x we got as 2 on 2, going by the formula, delta x on 2 open a square bracket, f of x naught. Our x naught we obtained as 1, so this will be f of 1 plus 2 f of 3 plus 2 f of 5 plus 2 f of 7 plus the last term doesn't have a 2, so we have just f of 9. And we close our square bracket. So this is what we need. Take note, the first term and the last term do not have the factor 2. All the other terms in the middle have to be multiplied by 2. So we can go ahead to evaluate all of this. You can evaluate separately, or you can just plug in the function into the formula and then you're done. But I always like to do it step by step. So here we need f of 1. F of 1, our f of x, square root of ln x. So this will be the square root of ln 1. That will give us 0. The next term, 2f of 3, or just f of 3. F of 3 would be the square root of ln 3. F of 5 will be the square root of ln 5. F of 7 will be the square root of ln 7. F of 9 will be the square root of ln 9. You punch all of these on your calculator, you're going to have some value. And then we just take those values and we substitute into our formula. So this would be 2 on 2, that gives us 1. Let me just put it here. So f of 1, which is 0, plus 2 square root of ln 3 plus 2 square root of ln 5 plus 2 square root of ln 7 plus the last term doesn't have a 2, so we have the square root of ln 9. And if you evaluate this, if you punch this on your calculators, you're going to get 8.905. And that is an approximate value for that definite integral we had given there. So approximating the integral from 1 to 9 of the square root of ln x dx using the trapezoidal rule with 4 strips, we obtain 8.905. Thank you so much for watching. I hope you learned. I hope you understood. If you have any questions or any doubts, please do drop them in the comment section and we will get back to you. As usual, it's been a pleasure having you, and until I come your way again, remain blessed.